Hey everyone, welcome back to the channel. Today I am going to show you how to turn an old Dell 65 watt laptop charger into a fully functional variable power supply, perfect for DIY electronics, testing circuits and saving money instead of buying a bench supply. Here's what we will need: Dell 65 watt charger which outputs 19.5 volts, and XL4016 buck converter for stepping down the voltage, and XL6019 to boost converter for stepping up voltage, multi-ton potentiometers to adjust the voltage and the current, a digital volt ammeter to monitor the output, a small step down converter to power that meter, and finally alligator clip for easy connections. So this is are all the components which we are going to use. So let's start. I'm going to use this container to store all our components. I'm going to install the power adapter on the back so that it will be easy to connect the power adapter, other components in the front. So before installing the power adapter, I am going to remove the case so that the transformer, capacitor and other components will be exposed, which will keep the SMPS cool, and it will be good for long term. So I tried, but it was almost impossible to remove the casing without breaking the adapter case. I have used my soldering iron to cut down the casing, and finally it is out of the SMPS is out of the casing. We are also going to desolder these power adapter wires and solder another 0.5 mm wire. Out of two part of a case, I am going to use one for mounting my power supply inside the container. I am not going to mount the SMPS directly inside the containers, so that in future if it is required I can detach easily. Before mounting, we also need to make some hole, so that we can connect the adapter. Here on the back side I am going to make the hole for the power adapter connection. I'm going to use my soldering iron. You can also use a knife for a good finishing. First I'm going to mark the hole according to the size of the adapter, and later I'm going to cut it down. I'm using knife for a better finishing. We need 4 holes to mount the case on the container, so I am going to use soldering iron to make the hole. Clean the holes using the knife, make it smooth. Make 2 holes on the container. Let's drill remaining 2 holes and mount the casing permanently inside the container. Let's try to mount the SMPS on the case inside the container. Okay, so it is fitting perfectly. In next step, we are going to desolder the wires of this SMPS and going to use a good copper wire. So I have already desoldered all the three wires from the SMPS. Now I am going to solder two copper wires, for one for the positive and for the negative terminal. I am going to use this boost converter XL 6019 to boost the voltage from 20 volts to 26 volt, so that I can get maximum output voltage. Okay, and also I can charge small batteries and also up to 26 volt 24 volts battery packs. And I'm also going to use this step down converter to power my volt and ammeter, which is going to used for monitoring the uh, output voltage and current. The output power from the Dell adapter, that is the red and the black wire, is going to be the input for the boost converter and the step down converter, that is 20 volts. So I am going to connect the red wire coming from the Dell adapter to the positive terminal of the boost converter, as well as to the positive terminal of the step down converter. Similarly, the black wire coming out from the SMPS will be connected to the negative terminal of the boost converter, as well as to the negative terminal of the step down converter. That is how the Dell output 20 volts is going to power on the boost converter as well as the step down converter at the same time. Don't worry, I will share the circuit diagram at the end of this video. You can go and check that for all the connections. Check the terminals of the step up boost converter and connect the wire properly. I'm going to power on the whole setup and set the voltage as per the requirement. In the boost converter I will set the voltage to 26.2 around, and in the step down converter I will set the voltage to 5 volts. Okay, you can use the potentiometer on the top of the step up converter and the step down converter to set the voltage as per your requirement. I have already done that, and also you can see the whole circuit is working fine. The output from the SMPS is used by the step up and the step down converter as the input power source. Let's disconnect the power source and connect the output of the step up converter to the input of the step down converter, that is the 4016 module, which is going to act as an variable power supply and control the voltage and the current of the output for our power supply. I have replaced the 10K pots with the 10K multi-ton potentiometer on the top of 4016 module, which make it accessible and mountable on the container, and easy to change the voltage and the current. Turn on the multimeter in the voltage mode. Connect your props to the output of the DC step down converter, and let's try to change the voltage using the potentiometer. So as you can see, the voltage as well as the current we are able to adjust as per our requirement. So the whole circuit is working fine, and we can move to the next step. So you can see here the output from the laptop charger is 19.5 volts. I'm sending that output to the input of the XL6019 module, where I am boosting it to the 26.2 volts and sending again to the XL4016 module. Then according to the potentiometer, as we adjust the potentiometer, that is a one for the current and one another for the voltage, we will get the output here, that is the variable output. The wire from the black wire from the output of the XL4016 is going to the volt ammeter, where it allows the voltmeter to measure the current at the output, and the yellow wire allows the measuring the voltage at the output. To power the this voltmeter, we need 5 volts, which I am using here again the LM2596 module, which is an step down converter, and I have I have step down the 19.5 volts to the 5 volts and sending it to the voltmeter. We don't require the black wire, or you can say the negative wire from this output, since we are already using a ground. So we can ignore the this uh, output. Okay, this is another diagram which shows the connection of the potentiometers, and how you can replace it with the existing stock potentiometer. I have already created another video on how to replace these existing potentiometers with the bigger one. You can just check the description, click on the link and check that video. So here on the cap of the container, I have drilled two holes for mounting the potentiometer, and two holes for taking out the wires for our output wires, and one for mounting the volt ammeter. Okay, let's mount the uh, whole thing inside the into the container, and do the connections and test it out. This is the wire from of the voltmeter, which is going to power the voltmeter and measure the voltage across the output. I am not going to use this black wire, and I have extended both the red as well as the yellow wire. I have already drilled two holes to mount the LM2596, and similarly for other modules also I have already drilled the holes using the soldering iron. I am going to use screws and nuts to mount these modules on the container. Use a screwdriver to fix it properly. We have successfully mounted the LM2596 module. Now we are going to mount the XL6019 module. Before mounting, we are going to connect the output from the charger to the XL6019 module, and later we are going to mount it using the screw. The red as well as the yellow wire is already extended. The yellow as well as the red wire, the output wire, is going to be connected to the output of the XL4016. Hence I am going to solder them together and connect it to the output. This black wire out from the voltmeter will become the output negative wire for us. On the left hand side we have another pointer which we are going to connect to the output negative terminal of the 4016 module. So we have completed the wirings, and you can see there are 4 wires coming out of the voltmeter. So these 2 wires, that is the red and the black, we are going to connect to the output of the 4016 module. We are also going to mount the both the potentiometer on the front, and later we are going to put this XL 4019 module inside the container. We are going to use this wire to power on the voltmeter. So I am going to connect it to the LM2596 output positive terminal. So all our connections are completed. Now let's try to power it on the power supply and check whether it is working or not. It is successfully power on. To set the output current, you can short both the wires and use the potentiometer to increase or decrease the current. Or the module has a built-in short circuit protection feature, hence there is no need to worry. I'm going to use a 24 volts battery pack to charge and show you as a load. So before charging, we need to set the output voltage of the power supply to 25.2 and current output to 2 ampere. Now you can see the current voltage of the battery is 22.1 and it is consuming 2.09 amperes of the current to get it charged. It will take some hours to get fully charged. You can adjust the current as well as the voltage using both the potentiometer that is mounted on the front. This bench power supply supports 26 volts output and 4 to 5 amperes of output current. You can use it for DIY projects, powering the motors, small components, and also charge the batteries. To learn how to create this 6S battery pack 24 volts, you can check the description and click on the link and check my another video. If you think this video is helpful, please like and subscribe the channel and share this video with your friends.